Here we are discussing question number 9 from miscellaneous exercise of the chapter Straight Lines. Question has been taken from NCERT book of class 11. Here question is, if three lines whose equations are y is equal to m1x plus c1, y is equal to m2x plus c2 and y is equal to m3x plus c3 are concurrent, then show that m1 into c2 minus c3 plus m2 into c3 minus c1 plus m3 into c1 minus c2 is equal to 0. So let us see solution here. Here equations of three lines are given. Given lines are y is equal to m1x plus c1. Suppose this is equation number 1. Y is equal to m2x plus c2, equation number 2, and y is equal to m3x plus c3, equation number 3. Since these three lines are concurrent, so the point of intersection of these two lines will satisfy equation of third line. Okay, so let us solve equation number 1 and 2 and we'll find value of x and y, and we'll put these values of x and y in equation number 3. Okay, so by 1 and 2, in equation number 1, y is equal to m1x plus c1. So in place of y in equation number 2, we can write m1x plus c1. In place of y, we are putting this value. And this is equal to m2x plus c2. This is equal to m2x plus c2, or m1 minus m2 into x is equal to c2 minus c1, or x is equal to c2 minus c1 upon m1 minus m2. Okay, we are getting value of x here. So value of y will be, putting value of x here, we will get value of y. So by equation number 1, let us put this value in equation number 1. Y is equal to m1 into x. So in place of x, we can write c2 minus c1 upon m1 minus m2 plus c1. This is value of y. So therefore, point of intersection of line 1 and 2, lines 1 and 2, is value of x is c2 minus c1 upon m1 minus m2, and value of y is m1 into c2 minus c1 upon m1 minus m2 plus c1. Okay, so this is the coordinate of the point of intersection of line 1 and 2, and all the three lines are concurrent. So equation number 3, equation of line 3 will be satisfied by these coordinates of point of intersection of line 1 and 2. So therefore, by equation 3, in place of x, we can write this value. In place of y, we can write this value. So y is equal to, means m1 c2 minus c1 upon m1 minus m2 plus c1. This is left hand side. Y is equal to m3 into x. In place of x, we can write this value. So c2 minus c1 upon m1 minus m2 and plus c3. Okay. Now for simplifying it, multiplying both sides by m1 minus m2. So we will get m1 into c2 minus c1 plus c1 into m1 minus m2 is equal to m3 into c2 minus c1 plus c3 into m1 minus m2. Okay, or multiply these factors, so we'll get here m1c2 minus m1c1 plus m1c1 minus m2c1 is equal to m3c2 minus m3c1 plus m1c3 minus m2c3. Here minus m1c1 and plus m1c1 will be cancelled out. So we are getting transpose all the terms in the right hand side into left side. So we'll get m1c2 minus m2c1 minus m3c2 plus m3c1 minus m1c3 plus m3 is equal to 0. So from these two terms we can take m1 common, c2 minus c3, plus from these two terms we'll take m2 common, c3 minus c1. From these two terms we can take m3 common. From here we are getting c1 and from here we are getting c2. This is equal to 0. So we are getting this result here. It has been proved. A very interesting question. Hope you understood it. So share this video with your friends also and remain in touch. We will see some more questions. Wish you all the best.